Have you ever stopped to think about the journey of your favorite protein bar before it lands in your hand, ready to fuel your day? From raw ingredients to that perfectly wrapped package, the creation of protein bars is a marvel of modern food technology. In this video, we'll uncover the intricate process behind bulk protein bar production, where cutting-edge machinery and meticulous quality control come together to meet the growing demand for these nutritious snacks. If this sounds intriguing, hit the subscribe button and give us a thumbs up to support the channel. Let's dive in. Protein bars have transitioned from niche dietary supplements to a mainstream snack option adored by athletes, busy professionals, and health enthusiasts alike. The market, valued at billions of dollars, is projected to surpass $6 billion by 2029, a testament to their widespread popularity. This growth is driven by an increasing focus on health and fitness, the rise of high-protein diets, and the convenience protein bars offer as a quick energy boost on the go. Factories producing these bars are under constant pressure to meet soaring demand without compromising on quality. To achieve this, they've embraced state-of-the-art production techniques that balance efficiency, innovation, and sustainability. The journey begins long before the factory floor with the sourcing of raw materials. Protein is, of course, the star ingredient. Depending on the recipe, factories may use whey protein, derived from milk, soy protein, a plant-based alternative, or pea protein, popular for its allergen-free profile. These protein sources are chosen not only for their nutritional value, but also for their ability to blend seamlessly with other ingredients. Additional ingredients include oats, nuts, dried fruits, sweeteners, and flavorings, each serving a specific purpose. Oats add fiber, nuts contribute crunch and healthy fats, while dried fruits and sweeteners enhance taste. Even flavorings like chocolate or vanilla are selected with precision to ensure they align with the brand's target audience. Before entering the production line, raw materials are often pre-treated. For example, nuts may be roasted to bring out their natural oils and improve texture, while dried fruits might be diced into uniform pieces to ensure even distribution. Each of these preparatory steps is carefully monitored to uphold quality and consistency. Once all ingredients are ready, they are sent to industrial mixers where the magic of blending begins. Mixing is far from a simple task. It's a science of precision and balance. Each ingredient is added in carefully measured quantities, ensuring the protein content, flavor, and texture are up to standard. The mixers are enormous machines capable of handling large batches of ingredients at once. Equipped with advanced programmable logic controllers, PLCs, these mixers allow factory operators to adjust key parameters like mixing time, speed, and even temperature. For instance, certain recipes may require a slower mix to preserve the integrity of ingredients, like oats or nuts, while others benefit from higher speeds to create a smoother texture. Consistency is critical at this stage. A well-mixed batch ensures that each protein bar offers the same taste and nutritional profile, no matter which one you pick from the box. After mixing, the next step is homogenization, where the mixture is processed to eliminate any lumps or inconsistencies. This step ensures that every protein bar has a uniform composition, both in terms of texture and nutritional value. Homogenization is achieved through specialized equipment that applies pressure or mechanical force to break down the mixture into fine particles, resulting in a smooth, cohesive blend. This step is particularly important for bars containing multiple textures, such as crunchy nuts and chewy dried fruits. The process binds all components together, preventing separation during the subsequent stages of production. With the mixture prepared, it's time for compression, where the ingredients are shaped into long sheets. Using large rollers or presses, the mixture is compacted into thin, uniform sheets that serve as the base for individual bars. This step is crucial for ensuring that the final bars are dense enough to hold their shape without crumbling or breaking apart. Compression also enhances the texture of the bars, giving them a satisfyingly chewy consistency. Factories often calibrate their equipment to apply just the right amount of pressure. Too much can make the bars too hard, while too little might leave them fragile and prone to falling apart. Next comes the extrusion process, where the compressed sheets are formed into continuous bars. The mixture is forced through a die, a specialized tool that determines the bar's shape and size. This continuous strip of protein mixture is then cut into individual bars using high-speed cutters. What makes this step remarkable is its versatility. Extrusion allows factories to create bars of various shapes and sizes, from the standard rectangular bars we all know to smaller, bite-sized versions or even round energy bites. This adaptability enables manufacturers to cater to a wide range of consumer preferences. For many protein bars, the next step is adding a coating of chocolate, yogurt, or other toppings. This isn't just about taste, it's also about creating a product that's visually appealing and marketable. The bars pass through an enrobing machine where they are evenly coated with the chosen topping. Once coated, the bars are sent through a cooling tunnel, a carefully controlled environment where the coating solidifies. This step is critical for ensuring that the bars maintain their shape and don't stick together during packaging. Throughout the entire production process, factories employ rigorous quality control measures. From automated sensors that monitor the size and shape of each bar to visual inspections for defects, every bar undergoes multiple checks before it's approved for sale. Advanced technology, such as AI-driven systems, plays a key role here. These systems can detect even the slightest inconsistencies, ensuring that only bars meeting strict quality standards make it to the next stage. Once the bars are ready, they move to the packaging phase. High-speed machines wrap each bar individually, using materials that protect them from moisture and oxygen, preserving their freshness and extending shelf life. The packaging is also designed to be visually appealing, with colorful designs and clear nutritional information that catch the eye of consumers. For multi-packs, the individually wrapped bars are grouped into boxes which are assembled automatically. This step is particularly important for meeting the diverse needs of retailers, from single bars sold at convenience stores to larger packs found in supermarkets. Each package is labeled with crucial information, such as the product name, nutritional facts, and batch number. This labeling ensures traceability, allowing manufacturers to track each bar from production to sale. In the rare event of a recall, this system ensures that affected products can be identified and removed swiftly. The protein bar industry thrives on innovation, constantly introducing new flavors and ingredients to attract consumers. From exotic flavors like matcha and salted caramel to functional ingredients like collagen and probiotics, the possibilities are endless. Factories equipped with modern technology can experiment with and scale up new recipes quickly, staying ahead of consumer trends. Sustainability is becoming a cornerstone of modern protein bar production. Factories are adopting eco-friendly practices, such as sourcing ingredients from sustainable farms, using recyclable packaging, and minimizing energy consumption through efficient machinery. These efforts not only reduce environmental impact, but also resonate with environmentally conscious consumers. The ability to scale production efficiently is what allows factories to meet the ever-growing demand for protein bars. By leveraging automation and advanced machinery, manufacturers can produce millions of bars daily, ensuring a steady supply for global markets. As technology continues to evolve, the future of protein bars looks brighter than ever. Innovations in AI, robotics, and food science will make production even more efficient, while new ingredients and flavors will keep consumers excited. The focus on sustainability will also drive the development of greener production methods, ensuring that protein bars remain a staple for generations to come. So there you have it, the journey of protein bars from raw ingredients to the final packaged product. It's a testament to the power of modern food processing technology and innovation. Honey, a natural golden elixir. Honey, often referred to as liquid gold, has enchanted humanity for centuries. From ancient civilizations that valued it as a sacred offering to its place in modern kitchens as a versatile sweetener. honey holds a unique spot in our lives. Beyond its sweetness, honey offers health benefits, including antioxidant, antibacterial, and anti-inflammatory properties. But have you ever wondered how this natural elixir is produced on a large scale? Today, we'll explore the fascinating journey of honey from bee to bottle, delving into the intricate processes that make bulk honey production possible. Before we dive in, don't forget to subscribe to our channel and hit the notification bell. We've got more fascinating content like this coming your way. And if you love learning about how your favorite products are made, give this video a thumbs up. The journey of honey production begins with the hive, a bustling community of bees working in perfect harmony. Each hive is a marvel of natural engineering, with its wax cells meticulously crafted in a hexagonal shape. This design isn't just visually appealing, it's also incredibly efficient, providing maximum storage capacity with minimal material. Within these wax cells, bee eggs hatch into larvae or grubs. Over the course of their development, these grubs are cared for by worker bees, which feed them a steady diet of royal jelly or a mixture of pollen and nectar, depending on their role within the colony. This nurturing environment ensures a healthy new generation of bees, ready to contribute to the hive's productivity. The hive operates as a well-oiled machine, with each bee playing a specific role, from cleaning and defending the hive to foraging for nectar. This division of labor is crucial for the success of honey production. Once a new generation of bees matures, the worker bees take on their most critical task: nectar collection. Armed with an acute sense of smell and remarkable navigation skills, these bees set out to find the best flowering plants. They fly from one flower to another, using their long, tube-like tongues to extract nectar. What's fascinating here is the dual functionality of the honey stomach. Unlike the bee's regular stomach used for digestion, the honey stomach is solely for nectar storage. As the worker bees collect nectar, they mix it with enzymes in their honey stomach. This initiates the transformation of nectar into honey, breaking down complex sugars into simpler ones. On their return to the hive, these worker bees engage in trophallaxis, a process where they regurgitate the nectar and pass it to house bees. This step not only helps with further processing, but also contributes to the unique flavor of the honey, as the bees' enzymes continue to work their magic. Once the honeycombs are filled with honey, it's time for beekeepers to step in. Harvesting honey is a delicate operation that requires careful preparation. Beekeepers don protective gear that includes a full-body bee suit, gloves, and a helmet with a veil. This ensures their safety, as bees can become defensive when their hive is disturbed. One of the most effective tools in a beekeeper's arsenal is the smoker. The smoker produces a steady stream of cool smoke, which has a calming effect on the bees. When exposed to smoke, bees instinctively begin consuming honey, preparing to abandon the hive in case of fire. This makes them less aggressive, allowing the beekeeper to work safely and efficiently. Beekeepers must also ensure that their tools are clean and sterilized to prevent contamination, maintaining the purity of the honey. The next step in the honey production process involves separating the honey-filled frames from the hive. Each hive consists of multiple frames, rectangular wooden structures that hold honeycombs. Beekeepers carefully remove these frames one by one, using hive tools to pry them loose. To minimize disruption, soft bee brushes are used to gently sweep the bees off the frames. This is done with precision to ensure that the bees are unharmed and can continue their work once the frames are returned. The extracted frames are then placed in hive boxes, which are neatly arranged to prevent any damage during transport. These boxes, now heavy with honey, are securely closed and loaded onto trucks, ready for their journey to the processing facility. Transporting honey-filled frames to the factory is a crucial step that ensures the integrity of the honey. During transport, the boxes are kept at optimal conditions to prevent spoilage. The journey to the factory is typically short, as time is of the essence to maintain the honey's freshness and quality. Once the frames arrive at the processing facility, they are carefully unloaded and inspected. Factory workers check for any signs of damage or contamination before the frames are sent to the decapping stage. This preliminary inspection is vital to ensure that only the best quality honey moves forward in the production process. In the factory, the first major step is decapping, which involves removing the thin wax layer that seals the honey within the combs. This wax, known as cappings, serves as a protective barrier, keeping the honey fresh and free from contaminants. Decapping machines are equipped with sharp rotating blades or heated knives that delicately slice through the wax on both sides of the frames. This process is done with precision to avoid damaging the honeycombs. The removed wax is collected and often repurposed for products like candles and cosmetics. With the cappings removed, the honey within the combs is exposed, ready for the next stage of extraction. The decapped frames are loaded into centrifuges, also known as honey extractors. These drum-like machines use centrifugal force to spin the honeycombs at high speeds, forcing the honey out of the cells. The honey collects on the walls of the extractor and gradually flows down to the bottom, where it is collected. This method is not only efficient, but also gentle on the combs, allowing them to be reused by beekeepers. The extracted honey at this stage is raw and unfiltered, containing bits of wax, pollen, and other impurities. However, it already exhibits the rich golden hue and distinct aroma that honey lovers cherish. To achieve the crystal clear honey you see on store shelves, the raw honey undergoes a thorough filtration process. It is passed through a series of fine sieves and mesh filters that remove any remaining impurities, including wax bits, pollen, and bee parts. Some factories employ advanced filtration systems that use pressure and mild heat to enhance the process. This ensures that the honey meets stringent quality standards while preserving its natural enzymes and nutrients. Filtered honey is now ready for bulk storage, a critical step in maintaining its quality before packaging. Filtered honey is transferred to large stainless steel tanks designed for food-grade storage. These tanks are equipped with temperature control systems that maintain the honey at an optimal temperature of around 70 degrees Fahrenheit, 21 degrees Celsius. Temperature control is essential to prevent crystallization and maintain the honey's fluid consistency, making it easier to handle during packaging. The tanks are sealed to prevent contamination, and routine quality checks are conducted to ensure the honey remains pure and flavorful. These storage systems can hold thousands of gallons of honey, ready to be distributed for various packaging formats. The next stage is packaging, where automation takes center stage. Honey is pumped from the storage tanks into automated filling machines. These machines are programmed to fill jars with precise amounts of honey, ensuring consistency in weight and volume. Jars are placed on conveyor belts, moving in perfect synchronization under the filling nozzles. Each jar is filled quickly and efficiently, minimizing waste. This automation not only speeds up production, but also maintains the highest hygiene standards, as human contact is kept to a minimum. Once filled, the jars move to the sealing station. Here, automated arms place lids on each jar and screw them tightly, creating an airtight seal. This ensures the honey remains fresh and prevents any leakage during transport. The sealed jars then pass through the labeling station, where they receive their branded labels. These labels provide crucial information, including product name, nutritional facts, and batch numbers. High-speed applicators ensure that every jar is labeled accurately and consistently, ready to hit store shelves. In addition to traditional jars, some factories produce honey spoons, pre-measured portions of honey molded into spoon shapes and individually wrapped. These are perfect for consumers who want a quick, mess-free way to enjoy honey. The process involves pouring honey into spoon-shaped molds, followed by cooling to solidify the shape. Once cooled, the honey spoons are sealed in individual wrappers, maintaining their freshness and providing a convenient option for on-the-go use. With all products prepared, it's time for bulk packaging. Jars and honey spoons are carefully packed into sturdy cartons designed to protect the contents during transportation. These cartons are labeled with shipping information and batch numbers for traceability. Before leaving the factory, each package undergoes a final inspection to ensure it meets quality standards. Once approved, the cartons are loaded onto trucks, ready for distribution to retailers and supermarkets worldwide. Modern honey production emphasizes quality assurance and traceability. Factories conduct rigorous testing at every stage, from raw honey inspection to final packaging. These tests measure moisture content, purity, and taste consistency, ensuring the honey meets regulatory and consumer standards. Traceability systems allow each jar of honey to be tracked back to its hive of origin. This transparency builds trust with consumers, guaranteeing that the honey is ethically sourced and of the highest quality. The journey of honey from hive to jar is a remarkable fusion of nature and technology. Every spoonful tells a story of tireless bees, dedicated beekeepers, and sophisticated machinery. As you drizzle honey on your toast or stir it into your tea, remember the incredible process that brought this golden nectar to your table.
Every morning, millions of gallons of orange juice arrive on grocery shelves, perfectly fresh and bursting with flavor. But have you ever wondered what it takes to get there? Behind each glass lies a story of precision, innovation, and thousands of hands working in sync to bring that sunny taste to your table. Today, we're diving into the mesmerizing journey of orange juice, from hand-picked groves to high-speed factory machines. Stick around, because this isn't just about juice. It's about unlocking the secrets behind one of America's favorite breakfast staples. Before we jump in, hit subscribe so you never miss another behind-the-scenes look at how your favorite foods are made too. The origin of orange juice. Orange juice has a history that's as vibrant as its taste. The concept of squeezing oranges for juice dates back centuries, possibly as far back as ancient civilizations that grew citrus. However, it wasn't until the mid-20th century that orange juice truly became a staple in American households. Advances in preservation techniques, especially the development of pasteurization and freezing processes, allowed for orange juice to be enjoyed year-round, not just during orange growing seasons. It soon became the iconic breakfast beverage we know today. During World War II, the U.S. government even promoted orange juice as a nutrient-packed food for soldiers, further cementing its place in American culture. Fresh squeezed orange juice contains no additives or preservatives, which gives it that rich, natural flavor many people love. It's packed with vitamin C, offering a great morning boost. But because fresh squeezed juice has a shorter shelf life, it's less commonly seen in grocery aisles compared to pasteurized, long-life orange juice. Processed juice is often pasteurized to kill bacteria and prolong shelf life, but the trade-off is that some natural flavor and nutrients may be lost in the process. The orange groves. The journey of orange juice begins long before it reaches a factory. It starts in the vast orange groves spread across warm, sun-soaked regions. Growing oranges takes time, care, and a lot of patience. Orange trees require several months to reach maturity and bear fruit. In the U.S., states like Florida and California lead in orange production, with their climate providing the perfect conditions for these juicy fruits. Come early November, these trees are loaded with ripe, bright oranges, ready for harvest. Timing is crucial because only when the oranges reach peak ripeness will they have the sweetness and juice content needed for production. Not all oranges are ideal for juicing. For mass production, Varieties like the Hamlin orange are favored. These small but mighty fruits pack a high juice content, making them perfect for large-scale production. Interestingly, these oranges are often picked while their skins are still green. A green exterior doesn't mean the fruit isn't ripe. It's just a sign of the unique sugars locked within, which give the juice a sweeter taste. Once harvested, oranges go through a rigorous sorting process. Pickers inspect each fruit as they transfer them from their bags. If an orange has a tear or puncture, it's discarded, as internal damage can lead to off flavors or spoilage. Minor blemishes, however, don't impact juice quality, so these oranges continue on their journey to the juicing stage. The washing process. The first stage in the plant is cleaning. Oranges are doused with soapy water, which is sprayed onto them as they move along conveyor belts. Rotating nylon brushes scrub away dirt, dust, and any other debris that may have clung to the fruit during its time in the grove. Once the initial wash is complete, a second sprayer rinses off any remaining soap. Brushes keep the oranges moving forward, ensuring they're spotless. This two-step cleaning process is vital to guarantee that the juice extracted later is free from contaminants or unwanted flavors. Air drying with fans. After washing, the oranges travel along a conveyor belt under powerful fans. These fans help dry off any lingering moisture. This drying step prevents water from diluting the juice and ensures each orange is ready for its final inspection before juicing. Once dried, the oranges pass through a secondary set of brushes with softer bristles. This last round buffs the fruit's skin to remove any last remnants of dirt or residue, giving the oranges a pristine look before they're inspected once more. The final inspection is critical. Inspectors check for any remaining damaged oranges that might have slipped through. This attention to detail ensures only the best oranges make it to the juicing machine, maintaining a high standard of quality in the final product. 14. Loading the juicer. Once inspected, the oranges are loaded into the juicer whole. This machine is designed to handle the entire fruit, eliminating the need for slicing or other preparation. Its efficiency is unmatched, allowing for the extraction of juice on a large scale. Inside the juicer, a fascinating process unfolds. Metal teeth puncture each orange, peeling back its skin to allow for maximum juice extraction. The machine separates the seeds, pulp, and membranes, leaving behind only the fresh, pure juice. The juice flows into a large vat equipped with filtering screens that can adjust pulp levels. Some people love their juice with a bit of pulp, while others prefer a smoother texture. These filters allow the juice to be tailored to meet different consumer preferences. The juice is bottled immediately, often in plastic jugs. These bottles are designed to expand slightly, which is crucial for storing unpasteurized juice. Because the juice is unpasteurized, it can ferment slightly, causing gases to build up. The flexible bottles prevent bursting while keeping the juice fresh. Instead of pasteurizing, this fresh squeezed juice is chilled immediately to lock in that natural flavor and vibrant color. This process results in a shorter shelf life, but delivers a flavor that's as close to fresh as possible, giving consumers an authentic taste. Once bottled, the juice is stored in refrigerated units. Fresh squeezed juice may not last as long as pasteurized varieties, but it's all about quality over quantity. This juice delivers a burst of pure, unaltered flavor that pasteurized juice just can't match. Finally, each bottle of orange juice is shipped off, ready to be enjoyed by consumers who crave that fresh, natural taste. With each sip, you're tasting the result of a long, carefully managed process, from hand-picking in sunlit groves to final bottling in a state-of-the-art facility. Next time you pour yourself a glass, take a moment to appreciate the journey it's been on to reach your table. Enormous water tanks equipped with powerful jets that scrub away dirt, debris, and any lingering residue. The washing process is so thorough that it leaves the potatoes looking almost pristine. It's like giving each potato a VIP spa day, ensuring they're squeaky clean and ready for the next phase. With their dirt and imperfections scrubbed away, the potatoes move on to the peeling stage. Unlike the old-fashioned way of peeling with a knife, Pringles uses advanced mechanical peelers that can strip away the outer skin of hundreds of potatoes in mere minutes. These machines are calibrated to remove just the right amount of skin without wasting valuable potato flesh. Once peeled, the potatoes are sent through high-speed slicers that cut them into thin sheets. These slicers are marvels of engineering, equipped with ultra-sharp blades that ensure each slice is uniform in thickness. Consistency is key here. Every slice must be identical to achieve the signature crunch that Pringles chips are known for. Here's a surprising twist. Pringles aren't made from whole potato slices like regular chips. Instead, they're crafted from a unique dough. After slicing, the potato sheets are made in signature shape without cracking. This dough is what sets Pringles apart from traditional chips. It allows the brand to maintain uniformity in shape and texture, delivering that satisfying pop and crunch with every bite. This stage is crucial. Too much frying could result in chips that are overly brittle, while too little frying would leave them soggy. Each chip spends exactly 11 seconds in the fryer, which is just enough to achieve that golden brown perfection. Here's an interesting fact. Unlike traditional chips, Pringles are seasoned on only one side. Why? Because the company found that this method delivers the perfect balance of flavor. The chips pass under a seasoning waterfall where a fine powder coats their surface. Whether it's the classic original sour cream and onion or one of the many bold flavors to your pantry. The Pringles factory operates around the clock, producing millions of cans every day to meet global demand. These cans are loaded onto trucks and shipped across the country and beyond. With distribution networks spanning over 140 countries, Pringles ensures that snack lovers everywhere can enjoy their favorite flavors, no matter where they are. But Pringles isn't just about making great snacks. They're also committed to protecting the planet. The factory has implemented numerous sustainability initiatives, including energy-efficient machinery and waste reduction programs. Kellogg's, the parent company, is actively exploring recyclable and biodegradable packaging options, aiming to minimize environmental impact. Despite the high level of automation, human workers remain an integral part of the production process. From overseeing machinery to innovating new flavors, their expertise ensures the smooth operation of the factory. Pringles is renowned for its bold and diverse flavor lineup. With over 25 flavors in the US and countless more internationally, there's something for everyone. Whether you're into the tangy kick of BBQ or the cheesy delight of pizza, Pringles. Ever wondered how many chips are in a can of Pringles? On average, each can contains about 100 perfectly stacked chips. That's 6 servings of snack time bliss. Next time you pop open a can, see if you can count them all before munching through. Pringles' unique combination of taste, texture, and packaging has made is driven by a passion for excellence. It's a testament to the dedication of everyone involved in bringing you this beloved snack. And there you have it, the incredible journey of Pringles from farm to can. The next time you pop open that signature seal, take a moment to appreciate the meticulous process that goes into every chip.
It might seem like a simple snack, but the story behind frozen waffles is a fascinating mix of history, agriculture, and cutting-edge technology. Frozen waffles have become a staple in American households, loved for their convenience and versatility. Today, we're peeling back the layers to explore how these breakfast favorites are made, from sourcing the perfect ingredients to the sophisticated processes in state-of-the-art factories. So, grab a cup of coffee and join us as we unravel the journey of the frozen waffle. Before we dive into the production process, let's take a moment to appreciate the rich history of waffles. Originating in medieval Europe, waffles were initially cooked using iron plates over open flames. By the 18th century, they became popular across Europe and America. However, the frozen waffle, as we know it today, came into existence in 1953, when the Eggo Company revolutionized breakfast with their frozen waffle invention. With the advent of frozen food technology, waffles transitioned from a time-consuming homemade dish to an easy, ready-to-toast delight. Frozen waffles owe their deliciousness to a few key ingredients, each meticulously sourced and prepared. Flour, the primary ingredient, typically made from high-protein wheat to ensure a light and fluffy texture. Eggs, provide structure and richness, sourced from large-scale poultry farms. Milk, adds moisture and flavor, transported from dairy farms in refrigerated tanks. Sugar, a touch of sweetness, often sourced from sugar beet or sugarcane farms. Leavening agents, baking powder and baking soda help waffles rise and achieve their airy texture. Flavor enhancements, cinnamon, vanilla, or other natural and artificial flavorings may be added depending on the variety. Flour production, from field to mill. The flour used in waffles begins its journey on expansive wheat farms across the U.S. Midwest. Wheat is planted in the fall or spring, depending on the variety, and is carefully monitored throughout its growing season. Once harvested, the wheat is cleaned, milled, and sifted to create fine, high-gluten flour ideal for waffle batter. Egg farming, quality and quantity. Eggs are sourced from large-scale poultry farms that prioritize freshness and hygiene. Modern egg farming includes automated systems for collecting, cleaning, and packaging eggs before they are sent to factories. Dairy farms and milk production. Milk used in waffles is sourced from local dairy farms and transported in chilled tanks to maintain quality. Many manufacturers work with farmers committed to sustainable practices, ensuring the welfare of animals and the environment. Sugar production sugar, often derived from sugarcane or sugar beets, is cultivated in tropical climates or temperate regions, respectively. Sugarcane requires year-round warm weather, while sugar beets thrive in cooler climates. After harvesting, the raw material is refined into granulated sugar, essential for giving waffles their hint of sweetness. Flavor additives. Natural flavorings like vanilla and cinnamon are often sourced from tropical and subtropical regions. For instance, vanilla beans are hand-pollinated and harvested in Madagascar, while cinnamon comes from the bark of evergreen trees in Southeast Asia. Once all ingredients are harvested and processed, they're transported to the factory. This phase involves careful logistics to maintain quality. Flour and sugar, shipped in bulk containers to ensure large quantities are readily available. Eggs and milk, kept in temperature-controlled environments to prevent spoilage. Flavoring agents, delivered in sealed packages to retain freshness. Sustainability. Focus. Many manufacturers utilize eco-friendly transportation practices, such as optimized routing and fuel-efficient vehicles, to reduce their carbon footprint. The first step in waffle production is mixing the batter. In industrial-scale mixers, precise amounts of flour, eggs, milk, sugar, and leavening agents are combined. High-speed mixers ensure a smooth, lump-free consistency. Temperature and humidity are carefully monitored to maintain the batter's quality. Industrial factories use computer-controlled systems to measure and mix ingredients with pinpoint accuracy. The batter's viscosity is tested frequently to ensure it can flow smoothly into the waffle irons. Once the batter is ready, it's piped onto massive automated waffle irons. These machines can produce hundreds of waffles per minute, cooking them at a consistent temperature to achieve that signature golden brown color and crispy texture. Advanced sensors ensure every waffle is cooked to perfection. Modern waffle irons are equipped with non-stick surfaces and temperature sensors. This technology guarantees that waffles don't stick and that every waffle is evenly browned. Factories also adjust cooking times based on the waffle type. Thicker waffles may take a few seconds longer to cook than thinner varieties. After cooking, the waffles move to the flash freezing zone. Here, rapid freezing locks in freshness and preserves the waffle's flavor and texture. The process prevents ice crystals from forming, ensuring the waffles remain high quality until they're toasted at home. Flash freezing occurs within minutes, at temperatures as low as -40 degrees Fahrenheit. This method preserves the moisture content, ensuring the waffles taste fresh once reheated. Before packaging, every waffle undergoes rigorous quality checks. Automated systems inspect for uniform size, shape, and color. Defective waffles are removed from the production line to ensure only the best products reach consumers. Quality control teams use infrared scanners and AI technology to detect inconsistencies, such as overcooked edges or uneven textures. Manual spot checks are also performed to confirm machine accuracy. Automated packaging lines. Once the waffles pass quality control, they're stacked and packaged in protective plastic wraps. Nitrogen flushing is often used to keep the waffles fresh by removing oxygen from the packaging. This step ensures the waffles stay crispy and prevent oxidation during storage. Boxing and branding. The wrapped waffles are placed in iconic branded boxes. The packaging includes nutritional information, cooking instructions, and eye-catching designs that appeal to consumers. Factories often run packaging lines at high speeds, producing thousands of boxed waffles per hour. To reduce environmental impact, many manufacturers have started using biodegradable or recyclable materials for their packaging. Storage in warehouses. Packaged waffles are stored in temperature-controlled warehouses before distribution. Proper storage ensures the waffles maintain their freshness and quality. Warehouses often utilize smart inventory systems to track stock levels and ensure timely distribution. These systems prevent overstocking and reduce waste. Transportation to retailers' frozen waffles are transported to grocery stores in refrigerated trucks. Efficient logistics and routing systems ensure the product reaches store shelves quickly, ready for customers to take home. Drivers and logistics teams follow strict protocols to maintain the cold chain, preventing thawing or temperature fluctuations. Convenience. Ready in minutes. Frozen waffles fit into busy lifestyles. Variety. Available in classic, whole grain, gluten-free, and flavored options. Versatility. Perfect for breakfast, snacks, or desserts, with endless topping combinations. Frozen waffles can be customized with toppings like fresh fruit, whipped cream, or even savory options like fried chicken. This versatility makes them a hit with families and individuals alike. The world's largest waffle measured over 8 feet in diameter. The Eggo brand name originated from the word egg, referencing their use of eggs in the batter. Americans consume approximately 164 waffles per second. Early frozen waffles were manually packed before automation revolutionized the process. From the wheat fields of the Midwest to the state-of-the-art factories churning out thousands of waffles daily, the journey of a frozen waffle is truly remarkable. Next time you toast one up, take a moment to appreciate the innovation, precision, and dedication that brought it to your plate. If you enjoyed learning about how frozen waffles are made, hit that like button, share this video, and subscribe for more behind-the-scenes looks at your favorite foods. Let's keep exploring the world of food production together.